Okay, this is an extension of the adding video that we did a while back. This will be solving rational equations, and I'm actually only going to do one example because this one has pretty much everything we need to do and it has a lot of steps. Okay, so be ready for these because these do take a while. Okay, so just quickly a reminder that for the addition of rational expressions or equations in this case, we need to have a common denominator. So that would be this piece down here, okay? And usually when you have something like this, it's usually going to be the trinomial one. So this is a binomial, binomial, trinomial. So just really quickly on the side, and there will be a lot of side work for this problem, we know that x squared minus 3x minus 4 is the same as multiplying two binomials. So like the unfoiling factoring, trinomial factoring, if that's what you want to call it. Okay, so this would be x minus 4 and x plus 1. Okay, so with that in mind, you should notice something here. You should notice that x minus 4 is part of it, and that's part of one of our fractions, and x plus 1 is the other part of it, and that's the other part of our fraction here as well. So pretty much both of these expressions, this one and this one, need one of the other, if that makes any sense, so that they all have the same denominator. So we're going to go ahead and multiply. We're going to multiply this one, the first one, by x plus 1 because it's missing x plus 1 on the bottom for them to be equal to each other. And we're going to multiply the second expression here by x minus 4 because it's missing x minus 4 to equal to this side, if that makes any sense. Okay, so we're going to go ahead and do that down here, and I'm going to scroll down a little bit. On the top, I would have 7 times x plus 1. I'm going to go pretty step by step over this whole thing. So x plus 1 times x minus 4 plus, that takes care of the first one. Now we're going to look at the second one. So I have all this right here, x plus 2 times x minus 4 all over, again, x plus 1 times x minus 4 is equal to what we had originally over here. So 5 over x squared minus 3x minus 4. Okay, so let me just really quickly go back and show you what I did here again. I'm trying to find common denominators, so this thing and this thing right here are now equal to this one because this trinomial factors out to x minus 4 and x plus 1, and since each of these already has one of them, we just have to multiply by the other one to make them equal. So the first one is missing the x plus 1, so I went ahead and multiplied that right here. The second one is missing x minus 4, so I went ahead and multiplied that right here. And now this, and this are all equal to each other. If it helps, and then maybe it'd be better if I showed this. This piece right here, remember, is equal to what I just factored. So I'm going to rewrite it. I'm going to rewrite this in its factored form because we did the factored form right here. Remember, this right here is the factored form. So they're equal. So I have x plus 1 times x minus 4. So once again, all denominators are now equal to each other. Okay? Since this is an equation, there's kind of a shortcut with these. If you have the same denominator, you can actually cross them all out and just look at the numerator. Okay, and that's just kind of a little shortcut we can use. So doing that, we're going to end up with 7 parentheses x plus 1 plus, let me make this a little bit smaller, plus x plus 2 times x minus 4 is equal to 5. And now here is where it actually gets a little bit more interesting because we have some techniques here that we've used in the past that maybe we just don't remember. Okay, so I'm trying to solve for x. So what some of you might want to do first is multiply right here. And that's correct. Okay, so 7 times x is 7x. 7 times 1 is positive 7. But then we have two binomials. So we have to multiply this whole thing by this whole thing. And we have done this as well. This is multiplying binomials. Some of you might know it as FOIL. Okay, so we do x times x is x squared. X times negative 4, because there's a minus there, is minus 4x. And then we do everything times the second number. So 2 times x is plus 2x. And then 2 times negative 4 is minus 8. And that takes care of the second piece right there. And again, this is all equal to 5. So now we have to combine like terms. So I'm going to go ahead and do that next. So I can see here that my biggest exponent is this one. So let's start with the x squared. Okay, so x squared goes first. Then I have x's. So I have 7x right here. I have negative 4x right here. And I have positive 2x right here. So I need to combine all of these. So 7x minus 4x is 3x. So these two are 3x. And then 3x plus 2x is 5x. So 5x. So I have plus 5x. So I'm going to go ahead and cross those out now. And all I did is I just added the x's together. Okay. And the last thing I'm going to look at here is my number. So I have positive 7 and minus 8. I can't look at the 5 yet because it's on the other side of the equation. So we'll deal with that right now. So 7 minus 8 is negative 1. And now I can bring down the equal to 5. So again, quick recap of what I just did. After I found the common denominator here, okay, so after we did this right here, because they have common denominators and there's an equal sign, all we have to focus on is the numerator to solve for x. So we went ahead and did that. So at this point, we have a lot of parentheses involved, so we just multiply here. Multiplying the first term here is distribution. So 7 times x plus 1 was 7x plus 7. This one was FOIL. So we multiplied this whole thing out and got everything here, and then just brought everything down. After that, we combined like terms, okay, which is the little circles and squares that I did here. And that leaves us to this point right here, okay? So now at this point, because there's an x squared, we're probably going to have to factor or use quadratic formula. Hopefully we can factor so we don't have to do too much work. However, before we do that, we should have this in standard form. So this point right here, we need this to be in standard form. And for those of you who don't remember, standard form is ax squared plus bx plus c is equal to 0. So we need to move the 5. So I'm going to go ahead and do that. I'm going to do minus 5 because it's positive, and minus 5 over here. And that leaves me with x squared plus 5x. Negative 1 minus 5 is negative 6. And now it is in standard form. Like I said, super long problem. Okay. So we're going to go ahead and figure out what x is here. So it looks like I can probably factor. Remember, factoring is what we did in the way beginning with that first trinomial. So I'm going to put an x in both places. And I know that negative 6 is the same as 1 times negative 6, negative 1 times 6, 2 times negative 3, and negative 2 times 3. This is just my list of factors. Okay, this is my list of all my factor pairs, if you want to think of it that way. And this is not mandatory. This is just in case you can't figure out the two numbers that add up to the middle, okay, because we're just factoring here. So it looks like for me to get a positive 5, I'm going to have to use this combination right here. So minus 1 plus 6. Because if I multiply negative 1 times 6, I get negative 6. And if I add them, I get negative 5. So those have to be my numbers. So this is equal to 0. And solving these two, we get that x is equal to 1. Remember, it's kind of like the opposite. And x is equal to negative 6. And we're done, right? Not quite. Okay, so again, like I said, this is a long problem. So once you get your solutions, you do have to do the final thing. Oh, we're out of space here, and check them. Okay, so I'm gonna go ahead and make some room here so we can check. Remember that when we're checking, we're pretty much just taking these two numbers and we're plugging them into the original to see if they work out. Okay, so I'm gonna go ahead and do that by plugging this into the original equation. So let's see, I'll use pink. I'll try not to take too long on this part. I know this video is kind of going a little bit lengthy for one problem. So my original equation, I'm going to go ahead and plug in the 1 first. So we have, let's see, 7 over 1 minus 4. And again, I'm just using the original equation from the way beginning. So pretty much wherever I have an x, I'm going to put a 1. So 1 plus 2. And then we have 1 plus 1 is equal to 5 over 1 square minus 3 times 1 minus 4. If you're not sure where I'm getting these numbers from, the 1, and I can highlight the 1 that I'm plugging in. The 1, this one is where all the x's were located. So I had an x here, here, here. I had an x right here and an x right here. And this is coming from this equation right here. So this whole big thing right here. Okay, this thing. So we're going to see if that's true. So let's see. 1 minus 4 is negative 3. So I have 7 over negative 3 here. Here I have 1 plus 2 is 3. 1 plus 1 is 2. So that means I have plus 3 over 2 is equal to, see, 1 squared is 1 minus 3. This is going to be 3 here. 1 minus 3 minus 4. What would that give us? 1 minus 3 is negative 2 minus 4 is negative 6. So I have equal to 5 over negative 6. So just like before, we have to deal with fractions again. So let's go ahead and find common multiples. If I want to get a negative 6 here, I would multiply this one by 2. Okay, and I would multiply this one by negative 3. So 2 times 7 is 14 over negative 6. 2 times negative 3 is negative 6. Plus 3 times negative 3 is negative 9. 2 times 3 is negative 6. Equal to 5 over negative 6. So now that we have the same denominators on the bottom, we can pretty much leave this out. And we can check 14 plus negative 9. Is that equal to 5? Well, I believe we end up with positive 5 on this side, because this is the same as saying 14 minus 9, okay? And that indeed is equal to 5. So that means that x equals 1 is one of the answers, okay? So this process we would do as well with x equals negative 6. You would check it, and simply because we're out of room, you're going to go ahead and have to take my word for it. This one also checks out. but the check process is the same. Okay. And I know that we don't like to do that very much because it's really time consuming and sometimes it could be, confusing, especially when fractions are involved. But it does pay off because not every single number will check out. Okay. Any questions, please come see me. These ones are definitely some of the more challenging problems. So if you need more help or you'd like me to make some more examples, just let me know and I'll be more than happy to. Okay, that's it.